This is Mr. Anderson for Keller Community College. We are looking at our trigonometry session 4, which is chapter 2, section 2. And it would be really handy if you had your unit circle. So if you've made a unit circle like this in class, it's good to have that. So please make sure you use this unit circle with this worksheet and you'll find things are going to be much easier. The first thing we're going to do is we are going to find from each of these locations the 6 trigonometric values of t from each of these points. Now you're not going to need the unit circle here because what we're going to see here is from an earlier lesson from session 1, we found out that the sine of any angle is going to be the y value of that because that's how it corresponds on the unit circle to opposite over adjacent, and since the opposite on a triangle there is going to be the y height over the, I said opposite over adjacent, I mean opposite over hypotenuse, and the hypotenuse is always 1, this is going to be your y value. So the sine of t is going to be negative square root of 3 over 2. Therefore the cosine is going to be the adjacent over the hypotenuse, which is your x over 1, which is x, so this is our cosine of t. Now from here, now that we know our sine and cosine, which is our y and x, then we can do the inverse of these for this problem. The inverse of sine is cosecant, so you could flip this on its head. The negative can move anywhere as long as there's one of them. And then we're going to rationalize the denominator by going square root of 3 over 3. So this is negative 2 square roots of 3 over 3. The secant is going to be the inverse of cosine, so bam, there you go. 1 over 2 is 2. Tangent is going to be y over x, so what we'll have is we'll have the negative square root of 3 over 2 divided by 1/2, which is another way of saying instead of dividing by a half, skip, flip, multiply. So you're going to skip the first fraction, flip the second fraction, and multiply. 2 divided by 2 makes 1. This makes negative square roots of 3. The cotangent is x over y, or you can flip just this problem on its head. So 1 over negative square roots of 3. So I'm just taking my answer here and flipping it on its head rather than doing it over here. And I'm going to rationalize this denominator by multiplying top and bottom by square root of 3 over 3. And this gives me square roots of 3 over 3 with a negative in front. Now, this is not one of our special values on the circle. I know this was actually one of our special spots on the unit circle, but we don't actually need that if we're just, applying the sine of y, sine of t is y, cosine of t is x. So we would just put our y value here, and we're going to put our x value here for our 6 trigonometric values of these locations on the unit circle. Flipping this on its head, this would be 5 over 2 square roots of 6. Multiply top and bottom by a square root of 6 over 6 to rationalize the denominator, because we can't leave a square root in the denominator, so 5 square root of 6 over 12. Yep, that's a 5. Yeah, I made that better. Alright, so what we'll do now is take a look at the flip of this, which is going to be negative 5. That's pretty nice. The tangent is going to be looking at the y value divided by the x value, but heck, let's not divide fractions, let's skip, flip, multiply, so this is negative 5 over 1. Those simplify, so this leaves me with 2 square roots of 5 over 1, which is just 2 square roots of 5. And then what we'll do is we will then make, I'm sorry, that should be a 6. There we go, change that to a 6 so I don't have to redo that problem. Now the cotangent is going to be y or x over y, but I just prefer flipping the tangent to give me the same answer, and I'm going to multiply top and bottom by square root of 6 to rationalize the denominator. So square root of 6 over 2 times 6, which will be a 12. So there's my cotangent. And it should be said here that I forgot my negative here in the tangent problem. That's my second mistake on that problem. And so I should have had a negative over here. So negatives all around for the tangent of t and cotangent of t. It looks like my t didn't show up right there. That's kind of funny too. Sorry about the little mistakes there, but hopefully you've rewound the video and figured those out. All right, we got 2 more here. Here's our 45-degree angle. This is a special spot on the unit circle, and this is where your y value and your x value are going to be exactly the same, which means that the tangent is going to be 1 because this divided by this is itself, or you can crisscross simplify and see that it does simplify to 1. This on its head is going to be 2 over square root of 2, and from our unit circle work, Some of you already know this memorized because this is going to give you 2 square roots of 2 over 2, or just square roots of 2. That's simplifying the problem by rationalizing the denominator, realizing both the numerator and denominator both have 2 in them. So the cosecant of t of that point is square root of 2, so is the secant. And that obviously makes 1 because the inverse of 1 is 1. All right, start over. I made a mistake on this problem here, so I'm going to start over. Let's begin with just listing out my sine of t, which is going to be my y value. And then I'm going to go with my cosine of t, which is going to be my x value. And I'll do the inverse here for my cosecant, which is the inverse of sine, and our secant, which is our inverse of the cosine of t. So here we go. We're going to take our negative 3 over square roots of 5, rationalize the denominator. So this is negative 3 square roots of 5 over 5. Now when we do tangent, these are both negatives, so we'll have a positive answer at the end. So this is going to be my y over divided by my x. So I'm going to skip, flip, and multiply this. 2 negatives make a positive. These simplify. This is going to give me 2 over square roots of 5. Now what's neat about this is going to be the actual reciprocal answer for cotangent of t. But I'm going to show you this end of this step here. So this is square root of 5, square root of 5. And this is going to make an answer of 2 square roots of 5 over 5. Now when we do the cotangent of t, we could flip this answer on its head. And I will actually do that right now, but I will show you that the answer is going to be actually worse just because you flipped the problem. Because if I rationalize the denominator now, multiplying top and bottom by square root of 5 over square root of 5, this is going to give me 5 square roots of 5 over 2 times 5. So this is 10, which simplifies down to just square root of 5 over 2, which is what I had right here if I didn't flip that. Some of you purists might notice too that, well, these are both, you could have taken your x value, which is your negative 2/3, and multiplied by your inverse of y value, because x over y would accomplish the same thing. So here's my negative 3 over square roots of 5. Let's see here. There's my, oh, whoops, I did my, all right, I'm going to edit that out too. Ha! Boop! All right, let's now move to the next page. Since this is a boop! On the next, we're going to find the exact value, and we're not going to use a calculator, but we will actually use some parts of the unit circles that kind of help us out here a little bit. It says do not use a calculator, so what I have to do is kind of think about cosine of 7 pi. Where is 7 pi? Now, one way to do this is to maybe think about a unit circle here, and how many, like, where is 7 pi? Well, this would be 1 pi, 2, 3, 4, 5, 6, 7. There it is at 180 degrees. So the cosine of 7 pi is asking for, in that location, the since cosine is the x, this is looking for this part of that coordinate. So this is going to be negative 1. Now for 7 pi over 2, you got to think to yourself here, like, okay, how many a pi over 2 is a 90-degree turn. So if I go 7 pi over 2, this is 1 pi over 2, 2 pi, 3 pi over 2, 4 pi over 2, 5 pi over 2, 6 pi over 2, 7 pi over 2 is right there at the point 0, negative 1. And what this says here is it wants the cotangent. And cotangent is our x over y. So this is going to be our 0 over negative 1. So our answer for the cotangent of 7 pi over 2 is 0. Cosine, negative 3 pi over 2. Okay, so for this picture right here, now remember every pi over 2 is 90 degrees here, so this is 1 pi over 2, 2 pi over 2, 3 pi over 2. The terminal side right here is at their 90 degree mark, and cosine is looking for the x value at 0, 1, so my answer here is 0. Now for the secant of negative rotation is a pi, well, that puts us at the 180 degree mark right there, and this is the point negative 1, 0, and secant is the inverse of cosine, so we have to take our x value and so the cosine of pi is 1, and take the inverse of that. The inverse of -1 is actually still -1. So there are my 4 values made good by the pictures there. Alright, so for the next picture here, we are going to find the exact values of each expression. Please use your unit circle for this here. So what I'm going to do is take my sine of 30 degrees minus cosine of 45 degrees. Now what I'm going to do is actually move to my unit circle and do the work on here. That way you can actually see where I'm getting these values. So in this problem here, I've got, let's see here, cosine of sine of 30 degrees minus cosine of 45 degrees. Okay, so we're going to look first of all at the sine of 30 degrees. So the sine is this y value here for 1/2. So this is going to be 1/2 for my sine of 30 degrees minus my cosine of 45 degrees. That's going to be my x value here, which is negative square root of 2 over 2. This can be simplified into 1 minus square root of 2 over 2, since this has a common denominator, and that's as far as I would take it. The book will actually factor out a 1/2, so their answer in the back of the book would be 1/2 times the quantity of 1 minus square root of 2. I kind of think this is a more logical answer. Alright, so let's now go back to, let's do the second problem. And again, with your worksheet in front of you, I'm just going to write the problem in the middle of this worksheet here. So this is going to be the cosine of 180 degrees minus the sine of 180 degrees. Okay, so let's go to the 180 degree mark, which is right there. The cosine is going to be the x value, so that's -1. And the sine is going to be the y value, which is 0. -1 minus 0. So the answer is -1. Alright, so going to the next problem here. Tangent of 45 times, since there is no operator between the two of these, cosine of 30 degrees. So there's an implicit, these are to be multiplied. So let's see, tangent of 45 degrees. So we go to our 45 degrees tangent. That's y over x. And if we do the y over x of this, we're just going to get an answer of 1, because square root of 2 over 2 divided by square root of 2 over 2 is 1. Cosine of 30, cosine being the x value, is this. So square root of 3 over 2. And 1 times square root of 3 over 2 is square root of 3 over 2. Alright, a couple more problems to go here. Let's do the next one. Let's do problem 12 here. We got the secant of 30 degrees times the cotangent of 45 degrees. Okay, secant of 30 degrees. Let's go to the 30 degree mark right here. Now the secant is the inverse of the cosine. So this is going to be 2 over square roots of 3. And that's going to be multiplied by the cotangent of 45. Now 45 degrees is here. That's going to be x over y, so that's just going to be multiplied by 1. Well, 2 over square root of 3 times 1 is just 2 over square root of 3. But we're going to rationalize the denominator, and this is one of our special spots on the unit circle, so this from memory should be 2 square roots of 3 over 3 for the secant of 30 degrees. Alright, moving on to the next piece. Let's go with, I think we're almost done with this video here, doing 4 more problems. Okay, so we've got a little bit trickier algebra here. We got 5 cosine of 90. Pen turned off there. Cosine of 90 degrees. 5 cosine of 90 degrees minus 8 sine of 270 degrees. Alright, so first of all, 5 times the cosine of 90. At 90 degrees, the cosine is the x value, so this would be 5 times 0. Minus 8 times the sine of 270. At the 270 mark right there, the sine is the x or the y value, so that's our -1. So 0 minus 8 times -1, the answer is a positive 8. Okay, more problems to do here. Let's go to the next one. Let's go with 2 sine of pi over 4. Plus 3 times the tangent of pi over 4. Looks like we're hanging out on the 45 degree mark there. Okay, so the sine of pi over 4, so the sine of 45 degrees is going to be square root of 2 over 2. So this is 2 times 2, or sorry, square root of 2 over 2. Plus, and here we have 3 tangent, so this is 3 tangent, which is, now here's the thing, tangent is y over x, so square root of 2 over 2 divided by square root of 2 over 2 is 1. So this is going to be, if I simplify this, square root of 2 plus 3. And I kind of like having my answers written this way because it fits the a plus bi form that we learned in Math 121. So even the book might have square root of 2 plus 3. This is a little bit closer to the a plus bi form when we deal with imaginary numbers. Okay, so there's your answer for that problem. Let's move on to the last two. Okay, so what we have here is 3 cosecant pi over 3. And then we have plus cotangent pi over 4. All right, so let's go pi over 3. So let's look at we're at the 60-degree mark. Cosecant is the inverse of sine, so we take our y and flip it on its head. So we have 3 times 2 over square roots of 3. And then what we will do is we will then add to that the cotangent of pi over 4. Now pi over 4 is at the 45-degree mark, and this is another example of 1 because that's x over y. So we got to rationalize this a little bit. There's nothing to simplify, so we have 6 over square roots of 3, multiply top and bottom by square root of 3 over square root of 3. This makes 6 square root of 3 over 3, which can be simplified down to 2 square roots of 3 plus 1. And 2 square roots of 3 plus 1, again, I would write it as 1 plus 2 square roots of 3, because in Math 121 you had a plus bi form for imaginary numbers, so we have our a term plus bi. That would be my reason for writing it that way. One more problem to go, and let's go with that. One more problem to go is the secant of negative pi. Oh, sorry, secant of pi. Sorry, that's not a negative rotation there. Minus the cosecant of pi over 2. So this takes us to the 180-degree mark. Secant is the reciprocal of, the inverse of cosine, and cosine is our x value, so that would be 1 over negative 1, which is negative 1, minus the cosecant, which is the inverse of sine. So what we're going to do is take our sine at our 1/2 mark right there. Sine is our 1 value there, and we're going to flip that on its head, so 1 over 1 is just 1, and so our answer here, negative 1 minus 1 is negative 2. And that's it for the first half of our 2-part video here today. Thank you for watching.